And so, yeah, so like I just mentioned, we're going to kind of going through the next, well, okay, we're focusing a little bit on section 6, data visualization. I'm going to talk a little bit extra stuff that maybe the curriculum hasn't gone into full detail. It'll be less about the strict technical, like how you program, to make visualizations. To be honest, I think sometimes that stuff can be a little kind of just like bend your mind a little bit. Like I always have a little trouble making that visualization just right. For the record, I have literally spent like 3 hours trying to put like a stinking circle on my graph, and I'm just like, come on, let's make this work. So if you've been there, or you're like, oh no, visualization sounds really great, and maybe you'll get there in the future, know that there's a lot to go through. Matplotlib, it's a really common one that we use, as data scientists. And if you ever look at the documentation of Matplotlib, I swear it must be like 800 pages long if you were to print out everything. Like it's a huge documentation of like all the things you can do with Matplotlib. So know that you do not have to be perfect, and know every single part in order to like, do a good job in an interview or be a good like a great data scientist. You use what you have available and you kind of find new parts. Like I said, the curriculum shows a lot of like details in this. I also say the Python Data Science Handbook, especially this stage in the game right now, it being free online, it having a whole section about visualization, how to use Matplotlib, is really useful. You might also find other like packages that are useful, like Seaborn. So I think the curriculum talks about Seaborn, right? Give me a thumbs up, nod. Okay, cool. So there's Seaborn. Some people might also find other packages. So there's like Plotly. There's also Altair. There's a whole bunch of different things, and really it just comes down to like what you enjoy. But what's kind of nice is that most of them have very similar syntax, where it's relatively straightforward to go from one to the other. So I won't go into that detail today. Maybe in the future, if you guys really want us to go through parts of it, I'm going to go talk more about like data visualization in general, as being like, what should you go through and what are the goals of this? So I'm going to share my screen real quick. And let's see here. So as I kind of share my screen, I have to find I think that's it. Sorry, they're like little tiny like windows. I'm like trying to figure out if that's the right one. Yeah, that's the right one. And my windows get moved around. Okay, so last time we talked a little bit, like more of the data, or not data, pandas and using data cleaning and stuff like that. So we talked about that. And then in the second half, we talked about some data visualization, like the motivation, how to use visualizations. I talked about, data source recs, how basically like you need to make sure that, or the reason why you use data visualization is one, you can convey information called explanatory visualizations, but you also might have, more exploratory visualizations, things that you're using to figure out something about your data. So I showed this visualization, this data source recs, where we had different data sets that all have the same X mean, Y mean, standard deviation for X and Y, and correlation. And they're all relatively the same, except for like, some rounding errors. And you can see that each data point right here, or each set of data is very different from each other. And this is where the power of data visualization is really good. Okay, so what we're going to talk about then is kind of like this guy right here, some good visualizations, why pie charts are not my favorite. And then we'll hopefully have the time for activity, and then we'll go into the parts for SQL and relational databases. Okay, so let's go right into good visualizations. So let me scroll up to the top here. Ooh, little preview for what you guys are going to see. Expand this guy out. All right, so we talked about like why we do visualizations, and the big part of, so can someone just tell me like overall, like why do we do visualizations? Like what's the point? If you were to kind of sum up like in a sentence.
Eyeball pattern.
Eyeball pattern, right? Yeah, cool. Yeah, so one thing I kind of mentioned is kind of like you're telling a story. You're really trying to just like give more of a narrative, like an explanation of your data, right? So when you're making this could either be a narrative, a story for yourself when you're doing exploratory, or it can be a story for someone else, whether that's someone who's technical, another data scientist, or non-technical, maybe someone who is like making decisions but not really familiar with data science itself. They just have, maybe familiar with like what they're supposed to be doing at that company or whatnot. Okay, so it's important to know like what we can do to convey information. And I mentioned last time, like we are a visual species, right? And we actually do a really great job in just taking information visually and understanding it. However, as you probably know, like if you went back like grade school, when you were like doing middle school, like what's it called, like illusions and stuff like this. Like sometimes your eyes can play like tricks on it. You know, you can focus on things that you're not quite. So it's important to realize like where humans do poorly at using visualizations to convey, to pull out information. So it's nice to kind of know, say, what are the possible things we can use in a visualization? What are the different, like, you know, attributes of it? So we have basically here 6 different parts, or I should say 5 different parts: position, length and size, shape, color, angle. You can see, don't use this part. And what those parts can mean in a visualization. So I'm just gonna show you guys some pictures as I kind of go through this part. So one thing is positions. Oh, I don't have a picture for this one, I guess. Position, where basically you're conveying information by where the data point lives in the graph or the visualization. So think of like scatter plots, right? Pretty straightforward. And then we have things like length and size. So this can be kind of like showing an effect. So for example, bar charts, right? Obviously, like we saw this from last time, is that something that's taller, right? Like, oh, this is more, obviously. You don't even have to look at like where these numbers are. You generally understand, oh, this is a bigger thing, it's a bigger value. You can also see stacked bar charts right here, where essentially we have our different sizes. So note that it's not just how tall this overall bar is, but also like the breakdown here. You can get a general feel for how much area is being taken up by this whole thing. So you can see here, this is US gun manufacturer by year. Or by the year, by type. So you see each year, it's like, oh, there were about 3 million guns made, right? And you can see that breakdown of that 3 million, you know, there's about 1 million were rifles, maybe like 0.75, you know, million were pistols and so on. So you can get a feel for this. This is kind of how we use like size and length and stuff like this. Note that I put a little emphasis here, showing effect, careful about area, is that one thing we'll talk about is that size, you know, usually I'm talking about like length and stuff like that, but size could also be the area of it. And it turns out humans are actually not the best at distinguishing similar areas with each other, even though they might be very similar and stuff like this. It turns out we're actually much better at determining length and stuff like that and comparing length size. So we'll talk a little bit about that. But you also see these scatter plots. People love doing these scatter plots when they do data visualizations, like adjusting the size of this, the point. So in the scatter plot, you can kind of see like these different points. They represent, you know, different points on this XY graph. And then the actual size of the data point representing some other third, you know, attribute. So in this case, you can see here, I think I pulled this off of the Seaborn actually, Seaborn's documentation. But you can see like total bill, tip, whatever that means. So probably something like, oh, this is how much the total bill was. This is probably how much tip they had. So in general, as you have a bigger tip, you know, or as you have a bigger bill, you tend to have a bigger tip, right? But you can see there's some fluctuation here. And it looks like whatever this is right here, the size of these data points are representing some other third attribute. I'm just gonna make something up. I don't actually know what this. Let's say how many calories there were eaten in this meal or something like that. So this could be like, oh, you have a third attribute on here. So this can put some extra information. Note that you be very careful about doing too much information, and we'll talk about that for visualizations as well. But just know that we can use size and length to represent more information. So sounds pretty good, right?
It could be how many people were at the table.
It could be that. Oh, that's a good point.
Group size.
Yeah, good. Good thinking. See, I try to make up stuff. I'm not as creative as like trying to make things on the spot, but I think that's probably what it really was. Makes sense. Okay. The next part we can also use is shape. So we can use shape to distinguish parts. So you can kind of quickly see here, this is kind of cheating a little bit because they're also using color, but you can see here each of the squares, the X's, the circles, the pluses, they each represent a different group in here. So you can very quickly determine, you know, what these different things are. Again, this is kind of cheating because they're also colored. So they're kind of using two things, just like as you should look at here, they actually use size, but they also use color and size. In general, it's that if you can do one of them, you should probably stick with one of them. One thing I'll note is that if these were all the same color, it might actually be really difficult to see this different shape, but you know, we can distinguish them. Also note that if these shapes are really, really small, like you can see these 4 different shapes, it might be really tough, but probably something like a plus and a circle, or even like a square and a circle, might be this distinct enough from each other that you can determine them. Okay. And then last one we have is color. Oh, not last one. Last one that's useful, color. So obviously color is a very quick thing to distinguish things. So these scatter plots, bar charts. we'll talk a little bit about this, but one issue you should really think about is people who are colorblind. There's actually a good proportion of people who do have red-green eye color blindness. And so you should always be aware of like what kind of color scheme you're putting in. For example, red on green is always a no-no. Never put red and green on top of each other, because if you have red-green color blindness, you're not going to be able to distinguish those parts, and it's going to be very difficult to like make that distinction. Is anyone here by chance colorblind? Okay, all right. Guaranteed, you know, give enough time, you'll eventually find someone who will, is everything. All right, and then last one is angle. So angle is a pie chart, and this is where I kind of like go a little bit in here. It's like, all right, so angle, we can say like, okay, as you kind of go across angle, that's kind of representing how much something represents. So for example, the classic pie chart, 23%, is 23% of the full 360-degree angle, right? You can also, in this case, actually represents with area, right? But the main idea is that it's supposed to be represented with this angle. So here's an example of a pie chart. And then a similar one is called a donut chart. I just love this one because they have a pie chart and a donut chart together. Like, I don't know why they had to do both of them, but it looks cool, I guess. Infographics love making really cool, but kind of purposeless visualizations. But you can see here is that in a donut chart, in a similar way, it's also using angle. Like, you can say it's area because it does translate directly over there, but really the main thing is that it's using angle to kind of determine where these things are. You'll also see this thing called racetrack charts. Again, infographics love this stuff. So you can see like a little bit of a racetrack chart here. And this is really, this can be really throwing off, I will tell you, because
looks impossible.
This is, what's that?
It looks impossible to read. Like, oh my goodness.
Yeah, you can kind of get, you might be able to get the feel for it, right? You start at the top and like as you move outward, right, that's more, right? The problem is like this one right here, let's say this green, and then this inside one is kind of like this pinkish, you know, red. This is about the same angle and they're supposed to represent the same thing. But if you look internally, it looks like sometimes your instinct might say, oh, this is actually smaller than this one here just because it takes up less space essentially. So this one's kind of having conflicting parts where essentially your angle is supposed to represent the value, but there's also area being represented here. And then also there's color, which in this case, I don't think there's any reason for this color other than it looks very pretty. I will say, you know, this is where I think Apple Watch has kind of like this diagram for like walking, or I don't know, I don't have an Apple Watch, but it has something like these circles that kind of overlap and stuff. And that became like a really like, I noticed it more after that had come out. People do this stuff. I will tell you right now, racetrack charts, they look pretty, but like they might not be the best at conveying information. Okay, so just to kind of back up, it's like, okay, Victor, like you got some like beef, obviously, with some of these things, like what's going on. So the big thing is that they're actual experts who've done research, like they do full studies and they actually try to say, okay, what are things that people misinterpret for visualizations? You know, like what are things that convey very easily? So basically, experts have found that like positional changes, so things like scatter plots, so like over here versus over here, are very easy for people to distinguish, like to a small degree, and length changes. So people can relatively quickly determine if something is longer or shorter than the other one. So those are like ones that are like, oh, those are very good ones. So that's the pie charts, or not pie charts, bar charts and scatter plots. Okay, things that are actually really difficult for people to have, or like at least it's inconsistent, are things like color hue changes. So like if you have like an orange versus a yellow, and it's like, and you have a spectrum of like orange all the way through blue, or let's say red through blue, and you have like the spectrum change, and it's like exactly what hue, people have a hard time determining colors. If you ever go, I just painted my nursery, right, like last week, when I went to go look for colors and stuff like this, do you know how many whites there are? Like in paint and stuff like this? Like there's so many different versions, and you really don't know until like you compare like next to them. Like you're like, oh wait, this is more white than like I thought it was, or this is more blue than I thought it was. People just have a hard time looking at color as an actual metric without comparing it with something else. So color hue changes can be very difficult. Area changes, okay? So area changes are actually really difficult too. And this is what pie charts are. And on top of that, angles are also really difficult for people to like really determine. So angles and angles and areas are actually really bad, which is what pie charts do. And that's why you really shouldn't use pie chart. But anyway, this is kind of like what you should focus on. If you want something that's made sure that's really clear, positional changes, think scatter plots, and length changes bar charts are usually a good bet. Anyone have any comments or questions or thoughts on this so far? Sound pretty good? Okay. So, all right, so let's kind of go through like, okay, what makes a good visualization then? So it's kind of nice to know what a good visualization is by looking at really bad ones, right? So the reason why bad, like I will say there are bad visualizations, like, this is where I'm like, okay, like, oh, there's, it's subjective, it depends. Like, no, there are definitely some bad visualizations that are basically either accidentally or purposely trying to hide information from you. So I like best, like they might accidentally kind of make it unclear. At worst, they're purposely trying to lie to you. So when something's trying to like mislead you, for example, like a visualization, like you should like, how do I say this? There are some like, hopefully you guys will never do this as a data scientist, but like there are definitely people who purposely try to make visualizations that make people misinterpret on purpose. The other thing they can do is hide data in there. So you can basically hide information behind other stuff by basically bringing people's attention towards something or making it seem like less of a big deal. We'll see an example of that. And distract. This is basically like, this happens a lot where people will focus on one part, like especially with colors. This is why in general, you really shouldn't have different colors unless it has a meaning to it, because it can distract, make people think other things or focus on the color where really that's not really an important part. Okay, so let's just kind of look at some stuff. I'll kind of quickly say is that, has anyone seen or read How to Lie with Statistics by chance? Okay, this is a great book. This is back, I want to say it's from like 1950s, maybe 1960s. It is a great book. People will reference it all the time. It is a great way to talk about like saying, like I mentioned, statistics being something that is giving you part of the information. And that's good for us, like giving us a summary of the information, just like with data source Rex, right? But you can also use that to try to hide information as well, or purposely, either purposely confuse someone or mislead someone, or accidentally mislead someone, get some information from you. And this is especially important as a data scientist, because a lot of times you're trying to convey information to someone who is not technical, who might not be familiar with this stuff, and you might accidentally mislead them with your visualization. Usually that's more like on an accident versus like purposely trying to confuse someone. Okay, so let's look at some examples of this. So in this book too, with How to Lie with Statistics, I talk about like chart junk. So chart junk is what you see in infographics. And this is like back a little bit, like maybe, this looks like the 90s, doesn't it, right? Kind of like, extra like, 3D kind of graphs and stuff like this. This is where like we say this is chart junk. There's too much going on to it. One is basically like this extra 3D, is this really necessary? Is it helpful? Also all these extra colors. One that gets me is always the lines, because like this one gets me right here. It's just like, they're three-dimensional lines and they look like they're overlapping, and they also have the lines on the side, but they're like kind of tilted in the side. Like it just adds too much trying to like convey information. So some general like rules of this is Edward Tufte basically came up with this idea called data ink ratio, where basically it's like, what is the ink that's being used for, and this is kind of funny because ink meaning like back before they had like, printers to do all this stuff, you have to actually hand draw all your data visualization, stuff like this. But the data ink being like the ink that would be used for the actual meaningful data, and then everything else. So you can kind of imagine it's like, all this like this texture down here, is that really useful? Extra colors and stuff like that, that would be like extra ink and stuff like that. So in general, some good practices, right, is using like heavy grid lines, or not, sorry, is making sure you don't use these things, is using heavy grid lines. You don't necessarily have to put in, like, for example, the whole point of a bar chart is that we can very quickly look how tall it is. You don't need these huge lines in here to distinguish those parts. Like that really shouldn't be necessary if your visualization is good. And if they are necessary, like there's such a fine tune, like there's such a minute difference, then maybe that's something that's not best represented by this visualization. Maybe you need to actually show those numbers, or another visualization that's zoomed in on it or something like that. But the important part is making sure like you're conveying actual information. Putting unnecessary text, this is where people like in infographics, again, love to put like text like on like the bars themselves, or like using like words as bars and stuff like this. And it's like, it's not really necessary. It looks cool, but like it just adds more, like it takes away a lot of like understanding of it. Also, pictures surrounding the visuals. Sometimes you'll see things like, I swear I've seen something like a cow like on top of like this other like visual, and it was just like, it was so distracting just as the background, and I just, all I could look at was this little like picture of the cow and thing, and just, it distracts too much. Like there's not a real reason to have it in a visualization other than that it's like, oh look, it's a pretty little cow. Shading or 3D components. For the record, if visualization should not use 3D. Like I will tell you right now, is that like, this is like, I would say most visualizations that have 3D in it are harder to understand than if you just made a 2D version of it. Okay. And then ornamented chart axes. So sometimes you'll see people like do little funky stuff and like little extra, like you can kind of see this extra fuzz down here, or they'll put like little icons and stuff like this, like to represent each tick mark. There's some weird stuff people do.
What if you're using 3 variables? Like,
yeah.
Then would a 3-dimensional graph be, make sense?
I would say that's probably the one exception that if it makes sense for what you're trying to convey, then possibly. But even then, like as a data scientist, like you'll use so many columns. Typically you have 5, 6, 8-dimensional data sets. And it's kind of like, you obviously can't make an 8-dimensional data set, right?
That would look very interesting, yeah.
Yeah, so generally what I recommend is doing actually multiple 2D plots, basically slices or projections of like a 3-dimensional plot itself. There are sometimes it makes sense, especially for clusterings, but then there's also techniques you can do as well. For example, this is going to be way longer in the course, but called T-SNE, T-SNE. That is a way, I'll just show you this real quick. Let's see if I can just images. It takes multi-dimensional data sets and projects it down into 2D, possibly 3D. It actually uses something called a manifold, but this is a little bit easier, and this can actually represent multi-dimensional data set, including 3D and 4D. So I generally would say this is probably good, and this is really useful in this case for like clustering. If we want to show things are very close together. T-SNE is not perfect for everything, but in general, when you're trying to do a 3-dimensional information, you generally see these points. If you want something more like positional data, the problem is that trying to convey depth with 3D data can be very difficult and not super clear. Like it could be misinterpreted depending, you know, like kind of like saying, oh, is it in front or behind? Or especially if you have something like 3D and like the size of the points can change, like kind of like we saw in one of the examples. You might have something like, is that point closer to me or is it bigger? And then you start getting these weird parts where someone can misunderstand, or you might misunderstand the information. So you just want to kind of avoid that as much as possible, but sometimes it might make sense. And one thing I'll say is that even though I'm saying this very like, this is bad, like you shouldn't do these things, obviously like these are closer to my opinions versus like direct, like these are the truths that you have to follow and like, you know, you better do this or else. But I think they're good guidelines by trying to make it simple, making it these parts, and then say, well, in this case, I think I can reason to break this rule a little bit. Those are fine in that sense, but you should always be aware of why you're doing it versus using the default of just like, ooh, 3D because 3D looks cool. Yeah. Cool. All right, good question though, and saying like when it would be useful. All right, so just a quick thing, misleading graphs, right? So this one is a really famous one. There's actually a real big debate about like visualization, like what you should do. I remember when I was taking a data visualization class back in like university, we talked about, you know, hurricane, and we actually talked about specifically Hurricane Katrina, about like saying, you know, what was conveyed and people misunderstanding like what the severity of this hurricane could possibly have been. And there was debate about saying, was this actually this kind of like this type of diagram actually shown, and misunderstanding what was going on. So if you just quickly look at this without reading too much of like what's going on here, this white spot right here, I'll tell you it's about a hurricane, right? What do you think this white like bowing part represents? Like, just looking at that.
The area of it over time.
Area of, sorry?
The area over the hurricane, the area of the hurricane over time.
Okay, that makes sense, right? Like, so like as the hurricane moves forward, right? Like, you know, Sunday, Monday, you know, through Sunday, through Monday, through Tuesday, that's like where it's going to be. And then like the area of the white spot, right, is kind of like how much space the hurricane's going to take over. Does that seem like a reasonable thing? Give me a thumbs up if that seems about right. Is anyone else kind of like yeah, that's kind of like what I was thinking, like thumbs up or, okay. That's completely wrong. That's not what is going on. So it is actually saying about time over time, but this cone right here is actually representing of saying the problem, 95% I think it's a 95% confidence interval, if I remember this right. Basically where the center of the hurricane will be. So this doesn't actually represent where the hurricane is. So you might think, if you look at this visualization and you're over here, like just outside this edge, you're like, oh, cool. I'm good. Like, I'm not going to be in this hurricane. Awesome. Or you might even think like, if you're right inside this white part, you're like, oh, good. Like I am on the outskirts of the hurricane. I'm probably just going to like a little breeze, you know, nothing too major. Where in reality, it could be that the hurricane goes straight through this part. It's just that this is the probability of like where they think the hurricane will be. And you can see here is that, you know, this visualization is bad. They know it's bad, for at least for the general public. If you're familiar with hurricanes, you probably understand what this graph is. But on the top here it says, note, the cone contains the probable path of the storm center, but does not show the size of the storm, which is immediately everyone thinks is, hey, that's the size of the storm. Hazardous conditions can occur outside this cone, of the cone. And you can see it's like, you know your visualization is bad if you have to put a note and say, hey, you know that thing that you think it is? It's not that. Like, this is those things where I will, you know, I'm obviously being a little too against this, is that if you're a climatologist, or I guess not climatologist, meteorologist, and you're familiar with these kind of visualizations, you're like, oh, I know what this means. I know it doesn't mean the actual size of the hurricane. But that's the whole point, is that this visualization is meant for a different, like a technical person who's familiar with that domain versus someone who's just like non-technical. And this is something that you have to be very aware of when you're making visualizations for your data and representing this data to someone else, is saying, is this going to be misinterpreted by someone who might not be as familiar with this data set or these, this domain as I am, or someone else. Okay, cool. Sound very good. Any questions or any follow up on this guy? Cool. All right, this one gets me. It's just, I just love this little note on top. All right. The lie factor. So this actually talks about like in language statistics. So the main idea here is that there's this really famous one of this doctor, and it's talking about like the shrinking doctor and stuff like this. And you can see here, they have a lot going on, but the main thing to convey is like, oh, so from 27% to 16% to 12%. And the thing about this is like, okay, we're going from 27, 16, 12. Again, we're using visualization to represent numbers. But the thing about this is that, what is representing the doctor size, right? So clearly we start off with 27% and then we go down to 16%. But it's like, is this the tallness of the doctor, or is it just the size of the doctor? Because the area is going to be different than just literally how tall they are. And this is what they call like the lie factor, where it looks like it's one thing. It looks like this doctor is shrinking drastically. But you can look at this 27 and 16, that's like less than half the size, like less than half the size, but this doctor is looking pretty small already. And this is the point, is that this is adding an extra thing that your person just quickly looking at this is not going to directly understand what's going on or misinterpret it. If this is someone who wants to convey, you know, over exemplify, you know, this doctor, the number or percentage of doctors devoted solely to family practice is shrinking, they might use this because it looks more drastic, where in reality, it might be a lot smaller drop off. This is a really famous one back in, it must have been 2000, 2001, something around there, early 2000s. And they talked about, you know, like what would happen if these tax rates expire and stuff like this. And you can see here, like, whoa, like that looks hugely drastic, right? And it's talking about like the tax rates itself. So it looks like 35%, and this is like 40-ish percent, 39.6%. And it looks like super high, right? That's like 1, 2, 3, 4, maybe 5 times as big. But if you think about that in the actual numbers, oh, that's 35%, and this is 39.6%. That's actually not that big of a difference. And it's because they started at this 34. And this is where you can actually, you know, mislead someone, like either purposely or by accident, is that when you look at this, it looks like a drastic effect. But in reality, it's like, well, okay, is this really as drastic as you're showing? And this is where like you might argue in, like there's definitely arguments saying not starting your axis at 0, but you have to kind of say, what is the point and what am I trying to convey? And this, you know, as a data scientist, ethically saying, am I conveying the thing that actually makes sense? Like, or am I trying to push, you know, something that I'm already seeing here? This is also something you can do by accident. So it's always good to kind of check yourself. Okay.
If I could just say, I actually do remember that chart because I saw it once and I never forgot it because I thought it was actually hilarious. Like there's only a 4% difference between those numbers, but they shape it to be like, a quarter of that number.
Right, yeah. And this is where like, this is a really famous one that had come up on like, it looks like the Fox News Network. And it was a big deal because like, definitely the people who put out this visualization definitely had a little bit more of a reason to make it seem more drastic than the other way around. And this is where like you also do, as a data scientist, you always think like, where are my data coming from? So yeah, but also you can do this by accident. Like, I want to make it really clear. It's like, sometimes there are people who are purposely trying to trick people, but it can also be done by accident too. And you have to be aware of it because you're for yourself. Okay.
Just a quick question about this.
Yeah.
Is there like any sort of like moral code for data scientists? Like if you had an employer that said, I'd like to drastically misinform people, would that be like, you could get hired for that, right? Like that.
Oh yeah, totally, right? Like people will totally say, hey, like we know the data says this one thing, but like, can you make this into a way that doesn't say that? And this is where like, like talking about like data source racks, like you can see already how quickly you can kind of like hide information if you're, if you are doing that, right? And I will even say is that sometimes it actually makes sense to not show all of the information at once because it just confuses people, or it makes people, like for example, showing outliers that are actually mistakes. Like even though it's more accurate to show those things that are maybe mistakes, it technically might not be the best thing because then you lose information of what you're showing. So like think of like a scatter plot, like, in general, like there tend to be these plots that kind of come out like this, but maybe you have like a data point that's like way up here. Well, it's going to try to, if you do a visualization, it's going to zoom out and kind of make this like almost a straight line in this data point. So it makes sense to take out that data point. There isn't like a strict, like I will say like, oh, like the oath of like the data scientist or something like that. But I do think it's a real thing that data scientists in particular, I think, try to like, at least, obviously, I don't know, I'm a little biased in this sense because like, saying, oh yes, data scientists are great, like we're trying to be very good. But I do notice that a lot of data scientists are aware of these kind of issues where someone can misconstrue information through data and obfuscate like the truth, like basically try to hide some of that truth with data. And I don't know, I guess like really, I think it comes down to just your moral standing, right? Just like, I think for pretty much any position in the world, right? For any job you can do, there's always things you can do that are like probably immoral, and you have to decide for yourself really. It's like, hey, this is not the right thing to do. I don't know if that's the kind of answer you're looking for, Stephen.
Sure. Yeah. I was just checking. Like in my current job, there's like a board and you would like get reported to the board and lose certification.
Yeah. Yeah. And this is where like, internal checks are really useful. One thing we'll talk about like with machine learning, and I'll kind of move on. Machine learning can have issues with encodifying biases and to the actual model and prediction, even though there's not a person in particular that's trying to, put out those biases, but like the data that way it was collected could potentially put those things out. We are starting to see more organizations put out, saying, hey, not only are we putting out this really cool thing that can do predictions, what are the potential harms or the potential, benefits for doing this thing? The one that in particular that I think of is like Google's scorecard for machine learning research. And so they'll actually have a scorecard that says, what are the potential benefits? What are the potential harms? Where does this data come from? What are, some potential things that could be improved for this data? And so the idea there is trying to be proactive, saying, hey, this is how this can be used. I will say like really quickly, facial recognition, for example, can be really, really beneficial in the sense like, let's say you're trying to find the missing child, right? And you can use facial recognition. Let's say you have cameras everywhere and stuff like that throughout the city. You can potentially find this child much quicker than if you had no facial recognition. However, there's also ways you can use facial recognition to be more nefarious, or target certain demographics or target certain groups of people on this. And this is where you have to realize is that just like all of technology and science is that it's definitely something like it's a tool, and you have to be aware of like what you potentially can use this tool and what kind of power you have over other people. So yeah, that's kind of like a little side note. but good thing to bring up, Stephen. So, and we'll definitely talk more about this too. Like, I think it's always a good thing to remind yourself as we're doing all this data stuff. Cool. All right, but back to visualizations and why they're awful. No. So some quick thing about 3Ds. So this one's also a really famous one. If you quickly look at this, which one looks like pretty big? You're like, oh, this green part right here looks pretty decently sized. Now you'll see here is that I think, I'm trying to remember in the original. I can't remember if, I think this is, they actually have the numbers on here. But if you look at this, it looks almost as if this 19.5 might actually be pretty decently sized. Like, it's definitely not the biggest one. 39 point in blue here is pretty big. But at least compared to this purple here, it definitely looks pretty big. And in fact, kind of comparing to the other parts, it's not super obvious. And this is partly because it's kind of on a 3D and it's kind of tilted towards you. And since it's kind of tilted towards you and it's closer to you and it's 3D, it's gonna have to look a little bit bigger. So this can actually make it seem very quickly like, oh wow, like, you know, green and apple here. Now this is where, you know, was this done on purpose? Was this done by accident? And people said, hey, it just happened to be apple was the one in front here. You know, that's a whole different debate. But the point is that this visualization can be really deceiving. So not only are they using a pie chart, which other reasons why you shouldn't use it, but also it's 3-dimensional, which is adding this extra information in there that might not be interpreted by everyone the same way. Okay. So this is why, again, you shouldn't use 3D if you can. All right, and then last one, just some color stuff. So tips for using color is start with black and white. So you can always start with black and white and then add color afterwards. Unfortunately, this is kind of kills me, is that almost every packet, visualization package does all the colors at once. Like, it's like if you make a bar chart with, you know, Matplotlib, Seaborn, it will color each bar a different color. Just start with, you know, ideally it should be all the same color because there's no extra information. Use less intense colors. So, you know, don't try to use all the colors of the rainbow. It's easier on the eyes, right? It might look a little more boring, but you avoid trying to, like, you know, for example, people focus more on yellow or, you know, other colors versus duller colors. So kind of helps things out. Communicate with colors. So one thing is that if you're going to use color, use it to highlight interesting groups. So like here's actually a really great visualization where it doesn't really matter what this data is, but the point is that there's a bar chart here and they are actually using the blue to emphasize a certain point in the data set. This 1971 by itself is nothing in particular, right? It's just another data point or, like, you know, a summary of data. But if this person's, you know, let's say presentation, like, you know, to another group and something like that, and they want to emphasize how in 1971, you know, we reached this peak value or something like that, or there's something special about 1971, they can emphasize this with color. And this is actually a really great strategy to do when you're using data visualization. It's like, here are the data through visualization, but then emphasizing your message. And remember, your whole point of visualizations is really to tell a story, is to tell a narrative, to understand this part. And that's why you always have to be really careful about telling the wrong narrative or purposely tricking someone into a different narrative. Okay, last tip, just don't add colors for the sake of color. I know sometimes people feel very like, I need to add all this beautiful colors to make it all pretty and stuff like this. Be boring sometimes. Like, and by boring, I mean, like, don't try to like make it super like fancy, beautiful kind of thing. The important part is conveying information. Can you still use color? Yeah. For example, like you can see this blue right here, light blue and darker blue. Like, that's perfectly fine. You don't have to have it purely black and white, but it's a good place to start. I will say is that sometimes it's nice to use color to kind of emphasize with like a presentation. So for example, if you already have a color theme going on, you can keep that color kind of going through your visualizations and stuff like that. Okay, sound pretty good? Cool. And then last thing, color blindness. Just use, if you're gonna use something that's gonna be like on a scale, use an orange to blue scale, orange on blue versus like red versus green. So you can see the simulated part right here where this is red and green here, and you can see what a simulated, what red, green eye color blindness would look like on the right here. So it becomes a lot harder to determine exactly what the scale is. And plus, scale of colors are not really the best because exactly when does something start turning into a different color is a different kind of story. Okay, cool. Man, I didn't realize I was going to take so long on doing this visualization part. But any questions about stuff we talked about? Yeah, pretty cool. All right, so I'm going to move on then to pie charts. So pie charts are awful. But actually, it's funny, when I first talked about this. I had like another cohort that we were talking about pie. That's like, oh, this is why pie charts are really bad. This video from Computer File on YouTube. I don't know if anyone's familiar with that on YouTube. Actually came out saying like they had this whole series of data analysis, and one of them was data visualization, and they talked about why pie charts were just bad. And I was like, oh, perfect timing. But the main reason is because of area and angle. It's just those are the two hardest things for people to understand consistently, like basically compare it, and pie charts do both of those things. And then in general, I'm not going to go on this full rant of going through it, but like the way people fix this, they say things like, oh, you should just put the highest percentage at the top and then smaller percentages as you go through. And you're like, but why didn't you just have it ordered to begin with? So what I'm talking about is like this visualization where they start with the highest percentage and they move downward over this way. That way you can make sure that this one's always bigger than this one over here and so on. It's like, well, then just use a bar chart. Like, why do you have to use a pie chart? And I'll tell you why people use pie charts. The real reason is because they look pretty. Like, and I don't know what it is, but business people love pie charts. Like, I don't know like what it is, but I've noticed that like with a lot of business companies, it's like pie charts are everywhere and stuff like this. So pie charts are kind of like, in my opinion, like kind of everything that goes through. And I have a little example of this with using the parental lobe. So we have our numbers here. If you see a bar chart, I can very quickly like tell these two different parts. But if I use a pie chart, you can very quickly see frontal lobe is very, like it's the biggest part. But then looking at like the green, the yellow, or green, orange, and the red, it's not super obvious which one's bigger by how much. Like maybe you could reason the orange is a bit bigger, but is it bigger and by how much bigger? Like where you're comparing something like a bar chart, it's very clear. It's like, okay, this is definitely taller than the other one. So again, reasons why you might not use pie charts. I've seen people argue, and I've had discussions with people of saying you can use a pie chart if there's only 3 variables, and like you can use it when there's very different sizes of each other. And I'm like, there's so many little rules, why even bother using it? So that's my opinion. I guess, you know, you can disagree with that. It's perfectly fine. But there's also some extra material that talks about like, you know, when to use pie charts and stuff like this, or alternatives to pie charts. One common one is using bar charts or stacked bar charts where you're doing parts of a whole. Another one is also a waffle chart. But there's this great article here that talks about like alternatives to pie charts and stuff. So something to check out. All right, so I kind of went through that pretty quickly, but any questions on pie charts or why I don't like pie charts? Cool. If you guys ever want to, I can go into full like rant mode about this, but I won't right now. All right, so I'll stop at that point here.